Hello students, let us see one more problem from CSIR-NET December 2024 question paper. So this problem is from electronics and you have been given a operational amplifier circuit. Now this operational amplifier circuit, if you carefully see, this is a low pass filter. Anyway, we are going to solve this one and you have been given a input, and input has a two parts. Your input has a two parts. I call this is a V1 and I call this is V2. So this is equivalent of two sources if you apply superposition principle. So what are you going to do? I am going to solve the output because of V1, input V1 and V2 separately. So my output has two parts. So my output will become two parts. This will be V01 and V02. Okay. So let us first analyze the circuit. And so I call this resistance is equal to ZI, and this whole I call is ZF. So this is ZI. So ZI is 50 ohm, and ZF. So ZF, they both are in parallel. So I can write 1 upon ZF is equal to 1 upon, I call this resistance R, 1 plus R, and 1 upon XC. Now let us solve this one. So 1 upon ZF will become 1 upon R, and XC is J omega C. So this becomes J omega C, and this comes out 1 plus J omega C R by R. So my ZF becomes R by 1 plus J omega C R. So this is my ZF. Now let me solve this ZF further. So ZF R is 100, and this is your 1 plus, this is J omega CR. C value is given 2 into 10 raised to power minus 6, and R value is given 100, that is 10 raised to power 2. And this can be written as a 100 upon 1 plus J omega upon, if I write this as a 5 into 10 raised to power, it's a 4 and 10 3, so 10 5 5 to 10 raised to power 3. Now why do I'm writing 5 into 5 to 10 raised to power 3? Because my input frequencies are 5 to 10 raised to power 2 and 5 to 10 raised to power 4. So this is the clearly, if I put omega is equal to infinite, this term will become if gain, this term will become 0. So this is an example of low pass circuit. Let me first write the output. Now I have the expression for the frequency, expression from the ZF. Now let me write first V01. What is V01? So V01, will be minus ZF upon ZI V1. And what is ZF? ZF, just now I have written what is the value of ZF. ZF value is 100 upon ZI is 50, and this is 100 upon 1 plus J omega upon 5 into 10 raised to power 3. Okay, and V1 is what? V1 is my 0.1 sine omega t. If you clearly see the input, first input, so this is 0.1 sine omega 1t. Okay, let me write sine omega 1t here. So now if I solve this one, this will be 1 2, so this will be minus 2. Okay, here I'll put now omega 1 because I'm putting V0 very well. So 1 plus J, and omega value is 2 into 10 raised to power 5 into 10 raised to power 2, and this is 5 into 10 raised to power 3, and you have a 0.1 sine omega 1t. Okay, now V0 will be, V01 will be, this is minus 0.2. Okay, sine omega 1t, and if I find this one, so this will be 1 plus j by 10. Okay, 1 by j 10. And now if I find the magnitude of this one, if you are in the in terms of phase, so phase will be simply phi. Phase of this number will be phi will be minus tan inverse 1 by 10 y by x 1 by 10. So this will be the phase of this number. You can easily calculate, simple thing. And this is equal to minus tan inverse 0.1. So this is almost equal to 0. If I calculate the 5, it will angle will come around 4 or 5 something. Okay. So there is a no phase change. So if I write the magnitude, this is the 0.1. If I take the magnitude also, so my final magnitude will come, V naught will come with phase. I'm writing it with phase also. Phase is almost a few degrees, so it is almost 0. So I can write my final answer will be minus 0 to sine omega 1, and this magnitude is how this magnitude will become 1 plus 1 1 plus 1 upon 10 square plus phase is e power minus iota phi is your tan inverse 0.1 0.1 0.1 tan inverse 0.1. So this is almost 0, and I can put this the phase. So your answer is coming minus 0.2, and this is almost equal to 1. So there is a no phase change. Okay, so there will be no change in the omega 1. So there will be only V naught 1. It will be minus 0.2 sine omega 1t is the one only. So there will be, so this is your V naught 1 because of V1. Okay, let me now find V naught 2. So V naught 2 will be what? V naught 2 again minus ZF upon ZI and multiply by V2. Okay, and we already have solved ZF and this one. So V naught 2 will be what? Minus 1 by 50, and this is your ZF is 100 upon 1 plus j omega upon 5 into 10 raised to power 3. And then now I'm using second frequency, second part. So this will become omega 2, and this is your sine omega 2t. Let us solve this one. V naught 2 minus, this will become minus 2 upon 1 plus omega value is 5 to 10 raised to power 4. So this become 10j and sine omega 2t. Now let me solve it further. So now if I solve this one, if I find the phase, okay, phase of this one, so how can I write? So let me calculate now the magnitude as well as phase of this number. So this is 100, this is 2 omega 2, and this is sine omega t. Let me check the input. The input is sine omega t. This is the 5 to 10 raised to power 4. Now we have already put the values. Okay, so this comes out now. This is 3 and this is 4. So this comes out 10. Sorry, here. So this comes out and 10j. Okay, let us now calculate the write in the phase and phase as well as magnitude. So if I write the phase, so phase of this number will be minus again tan inverse 10 by 1, tan inverse 10. So tan inverse 10 is around 84 degree, around 84 point something degree. Okay, so I can take it close as a 90 degree. Okay, I can take it as a 90-degree phase change. Okay, so if I write now, so this will become now magnitude minus 2, and magnitude of this one will be how much? Magnitude of this one, this will be 1 1 plus 1 plus 100 into sine t into phase is 90 degrees, so e power minus iota pi by 2. And if I solve this one, this gives me, again, if I solve this, give me 10, this gives me minus 0.2 sine. And if I write in terms of iota, okay, e power iota omega t minus e power minus iota omega t in terms of exponential, and if I solve this one, so it will show there is a phase change of pi by 2 omega. So this will be uh, omega t, so this will be omega t minus pi by 2. This is the phase change for due to the circuit. And if I solve this one further, so this is sine omega t, I can write minus, I can take minus common, so sine will be plus 0 point sine pi by 2 minus omega t, and pi by 2 minus omega t is cos omega t, so this become 0.2 cos. Here we are writing omega 2 omega cos omega 2t. Okay, so now I have the answer 0.2 cos omega t. Okay, so 0.2 cos omega t, and first one I have a 0.1 sine omega 1t. Okay, we have already solved. So this is minus 0.2 sine omega t. So the option 2, option this one. Okay, number change. This is option 1, 2, 3, 4. So this is the correct option for this question. So hope you like the solution. Please like and subscribe my channel. Thank you very much.